All right, so in question 5, we're asked to find the work required to move an object along the parabola y equals 2x squared from the origin to the point 1, 2 under the force field F, which is y comma negative x. And then it says to explain the sign of your answer. So as we looked at in the last video, we can interpret this line integral of our vector field F over a curve C as the work done by that field in moving an object along the curve. So here I have our path, which is just this portion of this parabola, y equals 2x squared. So I'm just going to parameterize this by setting x equal to t, so then y would be 2t squared, and t will vary from 0 to 1 as we move from the origin to the point 1, 2. And here's our vector field, y comma negative x. And so to compute this line integral, which is going to give us the work done by this vector field to move an object from the origin of the point 1, 2, we're going to integrate our vector field f evaluated along our path, so f of rt, and then we're going to dot that with the derivative vector. Okay, and here we'll be integrating from 0 to 1. All right, so let's go ahead and find this part, the f of r of t. And if this is f, then if I evaluate f along our path, then I'm going to set x to t and y to 2t squared. So that's going to give me the vector 2t squared, because that's equal to y, and that's our I component. And then negative x would be negative t. Okay, now we're also going to need the derivative vector, r prime. I'll compute that here. So this is going to be 1 comma 4t. And so then we can go ahead and punch those in. So we have our f evaluated along our path here in green, and then we're dotting that with this derivative vector in blue. All right. So let's go ahead and take that dot product, and then we're going to integrate the resulting expression with respect to t from 0 to 1. So here we're going to get 2t squared and then minus 4t squared. Okay, so 2t squared minus 4t squared is going to give us a negative 2t squared. Pretty simple. Okay, so then we're going to go ahead and integrate that from 0 to 1, and that's going to give us minus 2/3 t cubed. Evaluate from 0 to 1, and that's going to give us a minus 2/3. Okay, so we note here that the work came out to be a negative value, right? That's the value of this line integral. So why is this integral coming out to be negative? Well, if I look at this force vector as I move along my path, notice that as t varies from 0 to 1, your I component, which is 2t squared, will be positive, and your j component will be negative. Okay, so our vectors are going to point like this, okay? And as far as the unit tangent vector, t is concerned, well, that has the same direction as our derivative vector, and this thing has a positive I and j component, so it's going to point like this. And this angle here is going to be obtuse. And I can see why it's going to be obtuse, because if I look at the dot product, notice this quantity, negative 2t squared, it comes out to be negative. Okay, so I'm seeing here that the force vector here is actually going to be acting against the direction of motion as we move this object along the curve C. So in this instance, okay, the force is actually doing negative work to move that object from, in this case, the origin to the point 1, 2. All right, great. Well, that'll do it for this problem. Thanks.